Okay, so now we have cleaned two variables. So by the way, we redefined health status into health. So and hospital in this way. And you may want to rename this. I don't like this one. So I will use rename this as hospital. And then I change it. I made the names of two variables more intuitive, health and hospital. So that it's more intuitive what we are doing. And now what we I think we finished data cleaning. So then we have to check what's going on and if it's actually done by maybe there are many ways by just reading the browser. But this is not efficient. You cannot read all the numbers and looks fine. Just look through them and it looks fine. Another way to check what's going on in the variable is to use summarize. So for example, summarize, use command summarize will give you summary, literally summary. There are this many observations and mean is 3.87. So remember now, health is defined as the higher the better. So 5 being excellent, 1 being poor. So 3.8 is like large, and minimum 1, maximum 5. So it looks okay. And summarize, you may use summarize, like abbreviate summarize command into sum hospital. Then you get the same result. Hospitalization has either, 1 or 2. So 1 or 2 are the outcomes, and the mean is 1.91. Okay, it looks fine. By the way, you may also put two variables into one summary command, right? Intuitive. So summary is what you can see. And then it looks fine, but I am wondering, another thing you may be wondering is how many people were hospitalized actually. So then the possible thing is, or the possible command is, you may use count if. Count if hospital equals to 1. Again, double equality here. It's a logical comparison. Count if hospital equals to 1. Then it shows 5,800. About 5,900 people have been hospitalized overnight in the survey. Similarly, you may then how many people were not hospitalized? 66,000, right? So count shows you the number of a certain variable, and actually there is a simpler way to do this. Tabulate. Tabulate is to make a table. So now so a hospital is a simple variable. There are only two values. So count is enough. But if you want to study what's going on with health, you may want to use tabulate health. Then it tells you the health status by 1 through 5 and frequency. This is the number of observations in each category. So for poor health status, there are 1,700 observations, which is 2.35% of the observations. And excellent health, 25,000, which is about 34% of the total observations. And this is cumulative probability. So tabulate is another possible command you can use. And you may abbreviate tabulate into tab. Tab is another way to do the same thing. So then you can see that only 8% have been hospitalized. So makes sense, right? And what else? Another thing useful is histogram. Histogram takes a little bit of time. So simply histogram and the name of the variable will give you a graph like this. So for this graph, this is the description, and 1 has this much, and 2 has this much. So it's the graph histogram. You may edit the graph, but if you are to make a graph, I would make the graph on Excel. I don't know how to edit graph here. Like maybe Excel graph will be more will be better, prettier. And you may abbreviate histogram into HIST like this. So if you draw the histogram for health, then 1 poor, fair, good, better, excellent, something like that. So most people are excellent or great and good. So this is how we look through the variables. After cleaning out the data, you have to see if there is any problem, if there is any missing value. By the way, I have to tell you how to check the missing value. Count if health equals dot. A simple dot is the dot means a missing value. So if there was a missing value, then it will tell you how many missing values you have, right? So dot, it stands for the missing value. So drop if, usually we use this kind of command very often. If missing, drop, right? So, but in this example, in this data set, the data set have been already cleaned very well by CDC. So we do not need to take care of the missing values. But often in many examples, missing values are common problem. So that's another thing I wanted to tell you. Okay, so we did a lot of things, and now let's go to the textbook table. So now it's time to make the table that exactly the same table in the textbook. And what we did is we divide the sample into two groups, hospitalized and not, and then calculate their health status for each group. We are going to use command mean. So if you type mean health, then this calculates mean and standard error at the same time. So this is what we are going to use. But we are going to do this for each subsample, subgroup of hospitalization. And to do that, the command is like this. Over, and in parentheses, put the variable. Then this will do what we want. So for hospital equals 1, those who have been hospitalized overnight, the mean is like this and the standard deviation is like this. For those who have not been hospitalized, the mean is like this and the standard error is like this. So the numbers are different from the textbook because, as I said, the textbook data are 2005 survey, but we are using 2018 survey, and the sample sizes are different. Of course, the answers are different, but the conclusion is the same. What's interesting here is, remember, Now we define the variable as the higher the better. So the second group has higher average health status, better health, which means those uh, who uh, who went to the hospital have worse health. So maybe someone may interpret it as hospital is useless. Hospital is making people less healthy or something stupid. So that is obviously that is wrong. And guess why it's wrong and what's the problem. The data has no problem. Data is right. Data is correct, but still something is wrong. Some thing is not going well, and that's how you do how you replicate the table in the textbook. So you may be able to do a lot of things on Stata, but so and this will be the first homework, and I believe it's simple enough. And in the homework, I ask you a little bit more. So this shows you it calculates mean of health for each value of hospital. But what happens if you change that? So if you change the roles, then the outcomes are different, because now what we are doing here is we divide the data into 5 groups according to their health status. So for those who have poor health status, the mean of hospitalization is 1.6. And for those who have excellent health status, the mean is 1.95. So the mean is the mean of hospitalization, and it is not easy to interpret. So what's clear here is if it's close to 2 rather than 1, so this is close to 1 and it is close to 2, that means 1 is yes and 2 is no. So this group is less likely to be hospitalized, and this group is more likely to be hospitalized. And it's not easy to interpret, so what I suggest here is in this way. Replace hospital as hospital minus, excuse me, put it this way, 2 minus. If you change it this way, what it does is previously two hospital, 1 means yes, 2 means no. 1 is yes, 2 is no. But after this transformation, 2 becomes 0. So if you say no, 0, and if you say yes, 1 becomes 1. So 1 and 2 become 1 and 0. So, and if you redo it, now these numbers, the mean, implies the probability of hospitalization. So those who have excellent health status has only 4.3% hospitalization. But for those who have poor health, that probability is about 38.8%. So you see the difference as the health status get worse, more likely to be hospitalized, which makes sense. But the major difference here is when you define the variable, hospital variable, as 1 and 2, interpretation is not easy. However, I recommend you to consider 1 and 0. 1 is yes, 0 is no. And then the mean will be interpreted as the probability of yes, in this case, probability of hospitalization. So the interpretation would be better. That's uh, that's this is why a typical binary variable is defined as 0 and 1. So if you don't remember what is a binary variable, please review statistics. And finally, one final thing I would like to do here is t-test. T-test is to see if the averages are the same or not. The command is simply t-test, t-t-e-s-t, and variable health by hospital. This means what it does is you divide the sample into two groups according to hospital variable. Hospital variable divides the sample into two groups, hospitalization and not, and then across these two groups, it tests if this variable is the same or not. The averages of this variable are same or not. So in this case, as a result, so difference is 0 or not, and t statistic is like this, and the p-value is given here. For two-sided test and one-sided tests, p-value is 0, so everything is, so these hypotheses are this hypothesis is rejected against this alternative hypothesis. So clearly, the test result gives you that their averages are different across hospitalization groups. So this is just a simple review of statistics. And just what's important here is, so it would be nice if you understand how the t-statistics is calculated, but what's more important here is to understand the meaning of the p-value. You have to be able to interpret what it is. So H0, the null hypothesis, HA, which is alternative hypothesis. So the p-value is like this. Then does it reject or not? What is the significance value? What is the significance level? And please remind yourself of the introductory statistics concepts. Then that will help to follow this course. Okay, this is the end of this video, and it's what you need to do homework 1. In the next video, I'm going to show you a different function of Stata, that is writing a code. So far, I just demonstrate one by one command by one, but it is not how you program. So I will show you what real programming looks like. Okay, see you in the next one.